Hello. So we have been discussing the quantum mechanical ensemble theory in the last few chapters. Today we are going to discuss another class of system, quantum mechanical system, that is Fermi system. So we will start with the thermodynamic behavior of an ideal Fermi gas today. Okay. Now, for an ideal Fermi gas, we know that PV divided by KT is equal to summation log 1 plus z e raised to minus beta e. Okay, where z is equal to z is the fugacity, e raised to minus mu divided by kt, where mu is the chemical potential. Chemical potential of the system, and the average number of particles is equal to sum of the average number of particles in each single particle state. Okay, so this is which can be written as summation of 1 divided by z raised to minus 1 e raised to beta e plus 1. Okay, so this is the case for fermions or Fermi systems. Here z can have any value between 0 and infinity. Okay, there will not be any Bose-Einstein condensation type behavior here, because this fermion obey Pauli exclusion principle. Not more than one particle is allowed in any single particle state. Okay, so there will not be any condensation. Okay, Bose-Einstein type condensation in this case. Okay, if V is large now, if the volume of the system is large, then the energy levels are very close to each other. Therefore, we can say that energy level or energy spectrum is continuous. Therefore, we can replace this summation in these two expression into by integration. Okay, so that means PV divided by KT is equal to summation log 1 plus z e raised to minus beta e. If we integrate, we have to multiply with the total number of microstates. That means within the phase space. So total number of phase points. So that is A of E into D. So this is the number of phase points within the energy E and E plus D. So we have to multiply with this. We know this, what is the significance of these numbers. So where A of E dE, A of E dE is equal to, you know what is that value. So here, so we already know if there are only one state per energy level, then we can write that this is V times 4 pi p square dp divided by h cube. If we consider an internal, because of internal structure, there will be an additional weight factor, that is, we have to multiply with the g. G is the degeneracy of a level. Okay, so g times v 4 pi p square dp. So this is this. If you substitute the non-relativistic value, p is equal to p square by 2m is the energy. Then if you substitute the value of p from here, p is equal to root of 2m e. Substitute this thing, you will get g into 2 pi v divided by h cube 2m raised to 3 divided by 2 e raised to half d. Okay, so we can write then PV divided by KT is equal to, here K is the Boltzmann constant, is equal to integral from 0 to infinity log 1 plus z e raised to minus beta e g 2 pi v divided by h cube 2m raised to 3 divided by 2 e raised to half d. Now we can replace this beta e by x. That means put beta e is equal to x. Therefore, E equal to x by beta, or k times kt times x. Okay, which is or the differential dE is equal to kt dx. Okay. So substituting these values in the above expression, we get PV divided by KT is equal to integral 0 to infinity log of 1 plus z e raised to minus x into g 2 pi v divided by h cube 2m raised to 3 divided by 2. Here e raised to half dE. So ktx into kt root of kt into x and kt dx. So this will be equal to, so here 2m is already there, 2m kt whole raised to 3 divided by 2 x raised to half dx. So this will be g 2 pi v divided by h cube 2m kt whole raised to 3 divided by 2 integral 0 to infinity log 1 plus z e raised to minus x raised to half dx. This by parts, so this will be integral of this thing. So this will be log 1 plus z e raised to minus x integral of second term, so x raised to half x raised to 3 divided by 2 3 divided by 2 from 0 to infinity minus integral of differential of first term will be 1 divided by 1 plus z e raised to minus x into differential of this bracket. So z e raised to minus x into differential of this thing will be minus 1 integral of second term, so x raised to 3 by 2 divided by 3 by 2 0 0 to infinity. So when we apply the upper limit and lower limit, and we put upper limit e raised to minus infinity, so e raised to minus infinity is 0, therefore this will be log 1. Log 1 is 0 into this thing, so it will be 0. Then again lower limit, if we put x equal to 0, then this term will be 0, therefore this becomes 0 for all the both the values. Okay, then remaining thing will be minus of integral z e raised to minus x minus z e raised to minus x divided by 1 plus z e raised to minus x x raised to 3 by 2 divided by 3 by 2 dx. So this will become, before that we can divide with z e raised to minus x on both the numerator and denominator. So we can write this thing as g from 0 to infinity x raised to 3 divided by 2 divided by 1, sorry, z raised to minus 1 e raised to x plus 1 dx. Okay, so this 3 by 2, this will be 2 divided by 3. Okay, so we can write this, we can change this thing, we can make this thing 2 pi mkt, so that, so this pi goes inside and we can multiply with the root pi. Okay, so this equal to g times, and here 2 is there, so I will multiply with the root pi on both the numerator and denominator, so this will become g v 2 pi m k t whole raised to 3 divided by 2 divided by h cube. So this pi I have multiplied, so root pi I have multiplied, so therefore root pi 3 by 4. Okay. Integral from 0 to infinity x raised to 3 divided by 2 divided by z raised to minus 1 e raised to x plus 1 dx. So this integral, we know that this is, so the similar type of integral we have seen in the case of Bose-Einstein case, and here the only difference is this, the minus 1 became plus 1. So this function, we can write this thing as, this is h by 2 pi m kt, root 2 pi m kt is the thermal de Broglie wavelength, therefore I can write gv divided by lambda cube. So this can be written as 1 divided by gamma of, this is 1 divided by gamma of 5 by 2. Okay, gamma of 5 by 2 integral 0 to infinity x raised to 3 divided by 2 divided by z raised to minus 1 e raised to x plus 1 dx. Okay, so this quantity can be written as, this is called f 5 by 2 of z. Okay, so this is the Fermi Dirac function. Fermi Dirac function. Okay, so the Fermi Dirac function is defined by f nu of z is equal to integral, sorry, 1 by gamma of nu integral from 0 to infinity 1 divided by z raised to minus 1 e raised to x plus 1 x raised to nu minus 1 dx. Okay, so we got so this is the expression for PV divided by KT. Okay, Bose-Einstein function can be written in the series form as z minus f mu of z is equal to z minus z square by 2 power nu plus z cube divided by 2 3 raised to 3 power nu minus z raised to 4 divided by 4 power nu z. Okay, so here alternative terms have negative sign. Okay, so therefore we can write P divided by KT is equal to G divided by lambda cube F 5 by 2 of Z. So this, we can write this thing as equation number 1. Now we have also from so the average number of particles is equal to, we can integrate this thing also. So 1 divided by z raised to minus 1 e raised to x, sorry, e raised to beta e plus 1 e raised to beta e plus 1 a of e. So g 2 pi v divided by h cube 2m raised to 3 divided by 2 e raised to half d from 0 to infinity. So this is equal to g 2 integral 1 by z raised to minus 1 e raised to x plus 1 x raised to half d. Here we have, I have replaced this thing beta e with x, so accordingly the dE also will change. So this thing is dx. Okay, now so this can be written again as, this is equal to g 2 pi m kt whole raised to 3 divided by 2. So here I have multiplied root pi here, so I have to divide with the root pi here, root pi, and this 2 comes here. Okay, so gv 2 pi m kt whole raised to 3 by 2 divided by root pi integral x raised to half dx divided by z raised to minus 1 e raised to x plus 1. So this is, okay, sorry, one h cube is missed. So gv divided by lambda cube, gv divided by lambda cube f 3 divided by 2 of z. So this is also Bose-Einstein function of 3 divided by 2. So this expression is for n, average number of particles. So you can write n by v is equal to g divided by lambda cube f 3 divided by 2 of z. So this is expression number 2. So we have two expression. One is p divided by kt, g by lambda cube f 5 by 2 of z. So this is Bose-Einstein function. So this Bose-Einstein function can be written in the form of can be written as a series in the form of a series expansion z minus z squared divided by 2 raised to nu, like that. Okay. Now eliminating z between 3 and 4. Sorry. Now eliminating z between this expression 1 and 2, we get the expansion of the, or the equation of state of the Fermi. Eliminating z between 3 and 4. So eliminating z. So here z we have. Eliminating now eliminating z between equation number 1 and equation number 2, we get the equation of state. Okay. Before that, the internal energy. Now the internal energy. We know internal energy U is equal to minus beta of log Q, grand partition function, or which can again be written as kt square partial derivative with respect to t of log Q. Okay. Now this can be written as kt square by dot t of, this is equal to log Q is equal to the Q potential, which is equal to PV divided by KT. So we can replace PV divided by KT. So we have already derived the expression what is PV divided by KT. So this is equal to KT square. PV divided by KT can be written as dou by dot T of, so GV divided by lambda cube F 5 by 2 of Z. So this is okay. So this here this derivative is, this is the partial differential with respect to t. So we can put Z and V constant. Okay. So here if we put Z and V constant, then this will be equal to, so here lambda cube is proportional to 1 by t raised to 3 divided by 2, h divided by 2 pi mkt whole raised to 3 by 2. So if you differentiate this thing, so here z is constant, v is constant, g is already anyway constant, so this will become kt square. Okay, 1 by lambda cube will be t raised to 3 by 2, so this will be 3 divided by 2 g v divided by lambda cube f 5 by 2 of z divided by t. Okay, So t raised to 3 by 2 minus 1. So that is t raised to half. T raised to half. So instead of that putting that, I have taken t raised to 3 divided by 2 divided by t. So that t is kept. So to make this thing, so 3 divided by 2 kt into gv divided by lambda cube f 5 by 2 of z. So this is the expression for the internal energy of the system. GeV divided by lambda cube, this thing is P divided by, so this is PV divided by KT. So we can put it like this. So U is, we can write U is equal to 3 divided by 2, KT cancel, so remaining will be 3 divided by 2 PV. This can be written as P is equal to 2/3 of U divided by V. So the energy density, so pressure is 2/3 of the energy density. Okay. Also we can write the internal energy U is equal to, using this expression, N divided by V is equal to G by lambda cube F3 by 2 of Z. Potential function of 3 by 2. So we can write this thing, using this thing we can write this thing as 3 divided by 2. This is NKT f5 by 2 of Z divided by f3 by 2 of Z. So this is another expression for the internal energy of the system. So in terms of this Bose-Einstein functions. Now the specific heat of specific heat capacity. Cv is given by, it is the partial derivative of internal energy with respect to T with the N and V constant, number of particle and volume constant. So U is, for using this expression, we can write Cv is equal to 3 divided by 2. So first we can put Nk, 3 divided by 2 Nk. So this first term will be Nk f5 by 2 divided by f3 divided by 2 of Z plus, so I have differentiated this term. Then next is 3 by 2 nkt, 3 by 2 nk is there, t dou by dou t of f5 by 2 of f5 by 2 divided by f3 divided by 2 plus f5 by 2 of z divided by, so 1 divided by f3 by 2 square is minus f3 divided by 2 square into dou f divided by dou f3 divided by 2 divided by dou f by dou t. So therefore we can write, now let us see what is dou f nu divided by dou t. Okay, so this is equal to dou by dou t of f nu is z minus z square divided by 2 raised to, okay, so which is equal to, this is equal to, can differentiate this thing, so this will be 1 minus dou by dou z by dou t, so it will be 1, here this will be 2z divided by 2 raised to nu dou z by dou t, so dou z by dou t we can take it outside, so into dou z by dou t. So this is the dou f nu divided by dou t. So I can multiply with the z and so this will be, I will multiply with the z and I will divide it. Okay, so 1 divided by z, z minus 2z square divided by 2 raised to nu. So 2 raised to nu minus 1 it will become. So z square divided by 2 power nu minus 1 plus z cube divided by 3 power nu minus 1 minus z raised to 4 divided by 4 power nu minus 1 etc. Dou z by dot. Okay, so this is equal to f nu minus 1 of z into 1 by z dou z by dot. So this is the differential of Bose-Einstein function f nu of z with respect to t. So we may use that in the above expression. Also we have another expression. So we have n by v is equal to g divided by lambda cube f 3 by 2 of z. Using this expression we have dou f 3 by 2 t is equal to f 1 by 2 into 1 by z divided by dou z by dot t. Also we have, using this we just differentiate this thing with respect to t. So we can write this thing as, from this expression, from the equation number, using equation number 2, dou f 3 by 2 by dou t. Okay, constant v is equal to, v is 1 by n. Okay, v small v is 1 by n, which is equal to v by n is the volume per particle. Okay, so here we can write this thing as volume per particle means this is constant. So n by v is constant. So v by n is also constant. So we can take this thing as only g is also constant, lambda cube. So this can be written as dou by dou t of n by v. So this will be n by v is constant, because v is constant, g is constant. Therefore this lambda cube has 1 t raised to 3 by 2 dependence. Okay, so this will be equal to minus 3 divided by 2, t raised to 3 by 2 minus 1 it will become. So t raised to 1 by 2. So this can be written as t raised to 3 by 2 divided by t. So this will be n by v g lambda cube divided by t. Okay, so this can be written as minus 3 divided by 2 f 3 divided by 2 of z divided by t. Okay, so we have expression for dou f by f 3 by 2 dou t is equal to f 1 by 2 1 by z dou z by dou t. Okay, and this thing is minus 3 by 2 f 3 by 2 divided by t. So comparing this and expression 1 and expression 2, we get 1 by z dou z by dou t, constant volume per particle, is equal to minus 3 divided by 2 f 3 divided by 2 divided by f 1 by 2. Okay, f 1 by 2 on t is there. So this is the equation. So this is the expression for 1 by z dou z by dou t. So we can substitute these values. So we in this expression. So here, so Cv is equal to f5 by 2 divided by f3 by 2 plus t dou f5 by 2 dou t divided by f3 by 2. So this can be replaced, and this also can be replaced using these two formula. Okay, so Cv is equal to 3 by 2 nk 3 by 2 nk f 5 by 2 divided by f3 divided by 2 plus t. The first one is, this will be f3 divided by 2 z dou z by dou t, z 1 by z dou z by dou t. So this will be minus 3 divided by 2 3 divided by 2t f 3 by 2 of z divided by f 3 by 2. Okay, so this thing is the f5 by 2 divided by dou t f3 by 2. So minus f5 by 2 f3 by 2 square dou f3 by 2 by dou t. So this can be again replaced. So this will be minus f5 by 2 divided by f3 by 2 square into f1 by 2 f3 by 2 differential f1 by 2 into 1 by z dou z by dou t is minus 3 divided by 2 3 divided by 2t f3 by 2 divided by f1 by 2. Okay, so this is equal to therefore the expression for the specific heat capacity is 3 divided by 2 nk. So here f5 by 2 f3 by 2, so here 3 by 2 f5 by 2 f3 by 2, so 3 by 2 plus 1, see 5 by 2 5 by 2 into 3 divided by 2, so it will be 15 by 4 nk f5 by 2 divided by f5 by 2 offset divided by f3 divided by 2 offset minus 3 divided by 2 into 3 divided by 2, so 9 divided by 4 nk f3 divided by 2 of z divided by f1 by 2 of z. Okay, or we can write cv divided by nk. Cv divided by nk is equal to 15 divided by 4 f5 by 2 divided by f3 by 2 minus 9 by 4 f3 divided by 2 z f1 by 2 offset. Okay, so this is another expression for, this is the expression for, this is the actual expression for the specific heat capacity of the Fermi system. So we have found found PV by KT, then number of particles, then internal energy and specific heat. Next is Helmholtz free energy. Helmholtz free energy, A is equal to, what is A? The relation between G is equal to A plus PV. So A is equal to G minus PV. G is N times mu minus PV. Okay, so we know what is mu. Mu is equal to, or e raised to mu by kt is equal to z. Therefore mu divided by kt is equal to log z. So therefore we can write n times mu. Mu is kt log z minus pv is equal to, pv by kt we have pv divided by kt. What is that? Pv divided by kt is equal to g v divided by lambda cube f5 by 2, and also we have n is equal to, using n is equal to gv by lambda cube f3 divided by 2. Combining these two we get pv divided by nkt, just to divide with this thing, nkt is equal to f5 by 2 divided by f3 divided by 2. So divide this expression from this. Okay, so we'll get, so pv by nkt, So what is PV then? NKT F 5 by 2 divided by F 3 divided by 2. Or we can write NKT, okay. So in terms of this Bose-Einstein function, we can write the Helmholtz free energy also. Next is the entropy of the system. Entropy S is equal to U minus A divided by T. So what is U? U, we know that got 3 by 2 NKT F 5 by 2 divided by F 3 by 2. Okay. So so you remember that this 3 by 2 NKT, you just remember the case, the internal energy of ideal gas. So that is 3 by 2 NKT in classical ideal gas, 3 by 2 NKT. So the dimension of this U also the same thing, no? So therefore you can write this is U minus A. A is NKT log Z divided by F 5 by 2 divided by F 3 by 2. Okay. So we can write this thing as 3 by 2 NKT F 5 by 2 divided by F 3 by 2 minus here plus NKT F 5 by 2 3 by 2. So this is equal to 5 divided by 2 NKT F 5 by 2 F 3 by 2 minus NKT log Z. Or we can write, we can just once more we can simplify NKT 5 by 2 F 5 by 2 divided by F 3 by 2 of Z minus log Z. Okay. So okay, so that is enough. So the entropy is also done. So we have derived the relationship of various physical quantities in terms of the Fermi Dirac function F 5 by 2, F 3 by 2, F 1 by 2, etc. Now we can see the different limiting forms of this equation. So that we will discuss in the next class.